The second thing is about the neuromythologies. And these have really come about, as I said, through not understanding how the brain does things. For example, left and right brain thinking is really an over-interpretation of experimental results. Yes, you can put certain people, very right-handed people, into a scanner and give them some language tasks which certainly will preferentially activate the left frontal and temporal sides of their brain. But to extrapolate from that to the whole population, or to suggest that in a classroom language task, or the sort of task we're engaged in right now, that only half our brain's active, is a complete nonsense. You've got to try very, very hard not to get the rest of the brain to activate in an experiment. An experiment in a neuroimaging lab is really a completely different context to the reality of a classroom. Some neuromyths come from misunderstanding. The VAK learning styles misunderstands that our sensory modalities are separate. They seem separate to us on the outside, but interestingly in the brain, the messages are all interlinked. And what we see, the visual cortex processes that information and immediately sends a message to our auditory cortices to coordinate what we see with what we hear. Otherwise we couldn't do this interview. And with what we touch and with how we move are all integrated. Otherwise we can't operate in the world. So they're not separate senses, so we don't learn separately by them, we learn in a more abstracted way. So that's a misunderstanding. And some neuromythologies are just plain stupidly wrong. We can't possibly just use 10% of our brain, and there's plenty of evidence to show that even on the most trivial tasks we use nearly all of the brain. And in fact brain cells have to keep firing and interconnecting to stay alive. Or as I'm fond of saying, if you're down to 10%, you had better hope your relatives turn the machine off.
Right. So there's obviously a lot of challenges for teachers in working with this information, and I guess one of the measures of success for the summer school will be when teachers go back into their schools and look to implement some of their new learning. I'm just wondering, what sort of ideas do you think teachers might be able to take back readily into their teaching context?
Well, that's obviously the deliverable end of things, and I have had quite a bit of feedback and response from this. And I have to say, it's been all of it positive. What teachers have said is that they have intuitively, from their professional viewpoint, felt uncomfortable about these so-called brain-based schemes. It didn't seem to fit with the reality of the individual differences in kids and how they learn. And now they feel far more confident to go back to their schools and either ignore these things in their classrooms, which I think is what they've been doing, or maybe even in the context of professional development within the school, tell their headmaster, look, stop wasting money on this. You know, let's do something that's going to be far more benefit to the kids and so on. So that's a positive one. On the positive aspect, I think we could start looking at pedagogies that promote interconnectivity between areas in mathematics and so on. So that what we're doing neurally is establishing links between these different circuits involved in the different areas of mathematics. And I was interested in the keynote by Geake looking at some of the Australian mathematics competition questions. What's interesting about the questions, and the more difficult ones, is they're not just restricted to a single area of mathematics. They're not just an algebra question or a combinatorics question. You need to do a number of these things. And in fact, you could solve the questions by a number of different approaches and so on. And that seems to me a very fruitful sort of approach. The classic example in recent mathematics history, of course, is Andrew Wiles solving Fermat's last theorem. To do it, he had to show the connections between several quite hitherto disparate areas of mathematics.
Right.
And it was by establishing those connections he was able to solve the theorem. It's one of the lovely things about mathematics, I think, is that we explore these different areas and then discover how...
Yes, so we've got to open up the boxes and
get the connections. And I suppose the third thing is, with reference to John Pegg and the solo taxonomy, where John's been emphasising the changes in the information that goes to working memory as you proceed through the different layers of solo, from unistructural and multistructural, which from a working memory perspective we'd be talking about chunking and about automaticity and so on. So obviously, if we've got a good view of what we want kids to progress and cognitively develop, automaticity, that's going to give them far more power in solving complex problems and so on. And we certainly know that the young kids who struggle with arithmetic and number facts don't see, for example, that 13 plus 4 is essentially the same as 3 plus 4. They treat it as a separate phenomena, and so they've not been able to chunk that in the sense of a base 10 approach. So that, I think, gives us a steer as to how we might go about doing that.
Great. So, in a professional development program like this, teachers come away with a couple of new ideas, but there is a lot more to investigate and to understand for them to be able to implement in their own school environment. Are there resources that they can go to which would help them in doing that and to develop new ideas and that implementation?
Yes, certainly. Just in terms of resources that would support the sort of things I've been talking about and writing, we know that a number of articles I've written about mathematical brains and so on, they didn't exist as PDFs in a digital form, so they're being scanned. They'll go up on the summer school website, so they'll be available for teachers to access there. And if there's any difficulty or people want particular things or slides from my talk, they can email me at Oxford Brooks, and I'm quite happy to send things. And then finally, I must do a plug. I am writing a book, The Brain at School. It will have a chapter on mathematics in the classroom going from K through to 12 and beyond. And I'm very much hoping that'll be published sometime in 2009.
And who's going to be the publisher, John?
It's McGraw-Hill Open University Press.
Fine. Well, thank you very much for the overview today, and I'm sure that there will be people who will be interested in following up with you. Thank you very much.
Thank you, Russell.